This first episode of this programming series, I want to start off by talking about trees. Not the kind of trees you would see in programming, but just an actual tree, like this one right here. So, hopefully this will help anyone who's a little worried about programming. We're going to start off with very simple things. So, if I have a tree like this, I could describe this tree to you. I could say, its leaves are green. Or I could say it's 50 feet tall. And these would all be good descriptions of this tree. So, using your words and using numbers, you can describe this tree. Now, you may have heard, perhaps in middle school science, that there are two ways of describing things objectively. You can describe them qualitatively, and you can describe them quantitatively. So qualitatively would be what we see with green. We're using our words to describe a quality of it, while quantitatively we'd be using numbers, like 50 feet. We're using a quantity to describe the object. Now, in my opinion, I think you can describe anything quantitatively, but that's a little outside the scope of this video. But what you need to understand is that programming is no different from this. So just as I can describe this tree with my words or using numbers, whenever you create a program, you often need to deal with data, and you need to store things in data. And data you can just think as describing things in your program. You can use numbers or you could use words to do this. Now generally, when you're programming something, you want to keep it as quantitative as possible, because quantitative descriptions are almost always much more precise than qualitative descriptions. If I say that this is a green tree, well, there are many different shades of green, right? But if I give you the exact RGB value of this specific green, you know exactly the shade I'm talking about. So whenever you're making a program, you want to keep it quantitative, but this is where data comes from. It is a description of things. And so and we can break up data into types, essentially. So just as there are, different kinds of cars or different kinds of phones, there's different kinds or different types of data. So we can break data up into two most broad categories. We have numeric data and non-numeric data. So we'll start with numeric data, and we're going to be talking about primitive types, and I'll explain what that means shortly. But we'll start with numeric data first. So numeric data is anything that involves numbers. So the most basic kind of numeric data is an integer, sometimes abbreviated as int in programming languages. So an integer is exactly what you would imagine. It's just the mathematical integers, whole numbers like 1, 4, -6, 0, whole numbers, essentially. Then we have a slightly more complicated number. We have the float. And floats are decimal numbers. And they usually are not whole numbers, but they're not necessarily not whole numbers. Okay, that was a little redundant, but here's what I mean. You could have, say, 4.5. You could also have 4.0. And 4.0 is a whole number, but it's also a float. And the reason we call them floats is because all floats have a decimal point. See right there? And the decimal point sort of floats as you do mathematical operations on it. So that's where that comes from. And there are other sort of different types of numbers that different languages have depending on their size, such as bytes or shorts or longs or doubles and that sort of thing. But we're not going to talk about that here. It's a little outside the scope of this video. So now we're going to talk about some non-numeric primitives. And the most obvious non-numeric is the char. And the char is essentially just a character. It can be a letter. It can be a number. When you have a char that's a number, you're talking about like the word, not the quantity. So if I have, say, 4, that's like actually spelling out 4. I'm talking about like the word. If I have 4, I'm talking about the actual quantity of having 4 different things, right? So it's important you distinguish between the two, because you can't add, say, 20 and 4. You're not going to get 24. You're going to get something a little bit different than that. And we'll talk about that later in other videos, but that's the char. And we also have bools. And these are pretty interesting. These are either true or they are false. It is a binary of 2 possible states, essentially. And we don't necessarily need to be talking about things that are either true or false. We could be talking about whether or not something is turned on or off, or whether something is this or that. It's just anything that could be in 2 states we can represent as a Boolean. So, those are some pretty basic types right there. But we also have non-primitive types. And so we call these primitives. Let me just write that out. So these right here are primitives types. And when I say they're primitive, I mean that you can't break them up. I can't take the number 25 and turn that into anything else, essentially. It is sort of like the fundamental particles of programming. You can't break them down any further. But non-primitives, you can. Write that out. And a non-numeric non-primitive would be a string. And a string is literally a string of characters. So like a whole word, so say apple. Apple is a string because it is composed of 1, 2, 3, 4, 5 chars. I can break apple up into its constituent pieces. I couldn't do that with just a single letter. Or we have a not necessarily numeric data type. We have an array, which can be numeric, but not necessarily, and it can store numbers in order. And so this array can be broken down into the numbers that make it up. And these data types are very important in programming for representing different things. So if you had a person, let's say, you could describe them using an integer for their age, and maybe a string for their name, perhaps just a string, or potentially a series of integers for their eye color. And you can just, using these very basic types, you can just describe things. Just as you would use your words and use numbers to describe, say, a tree, you can describe things, anything really, on the computer using these basic data types. And using the data types, you can describe them in such a way that the computer will actually understand what you're saying. That's very crucial. So I hope this video helped clear up some confusion about what data types are. They're just different ways of storing information, essentially. And they're just the way you describe things and the way you store information in your programming, in your, say, code. So I will continue this series, and I hope to see you guys soon.